I'm Anil Kumar. Welcome to my mathematics series with Amy. Amy is a bright student from London, UK. We have an excellent strategy to understand the concepts and bring them to you. What we are really doing is first getting into the details of every topic and then selecting the best questions which have appeared in past test papers. You might know Edexcel shares their best papers, and this is the richest resource for any student worldwide. Amy selects some of the difficult questions which she fails to understand completely, and then we discuss them over on a Zoom call. That is what I share with you. And always we take up 3 or 4 topics. So that gives an overall view for any student who is preparing at this level, trying to get into the best universities globally. That is our objective. You can follow our series and learn while Amy is also learning. I hope you will enjoy this journey. In this video, we are going to take 4 topics which are based on modulus function, exponential and logarithmic functions, sequences and series, and calculus. The integration of these with some of the best questions from previous past papers will definitely help you a lot. Watch the video and enjoy the series.
Great, thank you. How are you?
Very good. Okay, so today, what do you want to do?
So I've been obviously revising for that test that I have after half term, and I'm like I've said, taking it like topic by topic. And so I've completed the whole trig, which I was perfectly fine with. Then it was arithmetic sequences and stuff, which I had 2 issues with, and then the functions modular stuff as well. So
Okay.
there's a couple questions from that, and exponentials and logs as well. It's kind of a bit, but yeah, a bit alright.
So let us discuss all the 3 topics and let's make the order kind of reverse order, right? So we'll
Okay.
start with exponential and logarithms, go to modulus function, and then to sequences and series, right? Okay.
Yeah.
So you can share your questions now. Perfect. So which question you want to do? Please read the question.
Oh yeah. So for exponential and logs, it was just like it's kind of a topic as a whole. I haven't been so specific because I did
I
just
see.
start this one. So yeah, could we start with one, and if we see any similar ones, we can just skip them.
Okay. So you should understand that exponential and ln, they are inverse functions, right?
Yeah.
Just as if you have x squared, to find the value of x, you do square root. Similarly, if we are given e to the power of something, you can take ln on both the sides and find the value. So they are like inverse functions. They reverse the operation.
All right.
So ln e to the power of x will be x. You get the idea, right? So they are inverse functions. So with that in mind, let's begin. Can you please read the first question?
Yes. So part A is 2 ln 2x plus 1 minus 10 equals 0. So we need to find the exact solutions in their simplest form to those equations. Yeah.
So we'll rearrange this equation and we can write ln 2x plus 1 as equal to what? We'll take 10 on that side and then divide by 2, which is 5, correct?
Yeah.
Now, as I said, we'll do e to the power of this. So both sides, you do e to the power of, right? So you do, so let me rewrite on this itself. When I write e to the power of ln 2x over 5, it is equal to e to the power of 5.
Yeah.
So when you do this, on the left-hand side, what you really get is
2x plus 1.
2x plus 1. So we have 2x plus 1 basically equals to e to the power of 5. Does make sense to you? They are inverse operation. That is why directly we could write like this.
Right.
So from here, 2x is equal to e to the power of 5 minus 1, and x is equals to e to the power of 5 minus 1 divided by 2. So that becomes the exact solution.
Yeah.
E is an irrational number. So if they tell you to round it to some decimal places, you can use calculator.
I
However,
see.
at this point, that will be your answer. Is it okay?
Yeah, that's clear.
Now let's look into part B.
So 3 to the power of x and e to the power of 4x equals e to the power of 7.
Correct. So we will again take natural log on both sides. Do you see that? So we'll write ln, and we have 3 to the power of x times e to the power of 4x equals to ln e to the power of 7. Is that clear to you?
Yeah.
Since it is inverse function. Now, that basically means what? We can apply the product rule of logarithms. So this will be written as ln 3 to the power of x
Add.
plus e to the ln e to the power of 4x. And here we get 7, correct? Because ln and e are inverse functions. Now applying the power rule to ln 3 to the power of x, I can rewrite this as x times ln 3.
Oh.
Here we have 4x equals to 7. Is that clear to you?
Yeah.
Now you can take x common, and within brackets you get ln 3 plus 4 equals to 7, and so x is equals to 7 divided by ln 3 plus 4. Does it make sense?
So I got a bit stuck in the first part. Basically, it
Hmm.
was I see how you got it, but
Yes.
I don't know. Yeah, I was trying to do something else, like the 3 to the power of x. You know, when you make the bases the same.
Oh yeah,
And
yeah,
both
yeah.
of those
No.
were e's, so I was just trying to go a bit complicated.
Yeah, apply the product rule.
Okay. So product rule, yeah.
Right. So
I think because I'm so used to seeing the product rule in the log form,
Log.
when it became ln, I was like a bit like thrown back. Okay, so that one makes sense.
So basically log and ln are same thing, right? So when you say log of x, we are saying this is kind of equal to log to the base 10 of x. Do you see that?
Mm,
But if I make log to the base e of x, that is actually written in short as ln x.
right.
So
And so that
base
one we call natural log.
natural log, and otherwise log to the base a or b, whatever of x you could say, right? Generally. So that is how all are same, but specifically ln is to the base e. And
I
if you
see.
just write
Okay.
log, it means base is 10.
Right.
Okay, next question. Find algebraically the exact solution of this. So we'll see the application of logarithms right here. So when I say ln 4 minus x plus ln 9 minus 3x equals to something, so on this side, I
The
can
product
write
rule.
this as ln, because this is plus, I will multiply them, right? So I can write this as ln 4 minus 2x times 9 minus 3x. Is that clear to you? Equals to 2 times ln, applying the power rule, ln x plus 1 whole square. So we have written in this form. Now, clearly, we have the equation before us. This part should be equal to both arguments, should be equal, correct?
Oh yeah.
So now we can easily solve this. We have got 4 minus 2x times, you can expand and solve, right? 3x is equals to x plus 1 whole square. Is that
Do
clear?
that now.
Yeah.
Yeah.
So now you can expand and solve. It's like a quadratic equation.
Yeah.
So we'll stop it here, right? And of course, note that the domain for x is given to you between -1 and 2. It makes sense, right? Because this cannot be negative, right?
Right.
It has to be positive rather. It cannot be 0 also.
Yeah.
So from here, you get your limit. The lower limit of -1 and the upper limit you get from which one? This one.
Right.
You get the idea. So that is the limit or the domain of this particular function. Sometimes the question will be just to find the domain. You get the idea?
And so you have to work the other way.
Yes, yes.
How would you know whether to take like how did you know it was the ln 4 minus 2x to be the upper domain? Why can't it be the 9 minus 3x?
Okay, let's figure it out. So basically, let us say we want to find domain, then we know 4 minus 2x should be greater than 0, right? Because it can be only positive. So let's solve for this. So we have minus 2x is greater than minus 4. So we'll divide by minus 2. The sign will change here, correct? And you get 2. So there you get. Do you see that?
But if you did the same for 9 minus 3x.
Yeah, you'll get your domain, which is less than 3, right? 9 minus 3x will give you another domain, right?
Yeah, so why can't it be 3?
No, because 2 is better, right? Do you understand? Less than 2, if it is less than 3, so this has to be greater than 0. You can write like this also, 3x, and then dividing by 3, 3 is greater than x, or x is less than 3. So on a number line, let's say this, right? So you have your point, which is, let's say 0, 2, and this is 3, right? If something is less than 3 and also less than 2, what will you prefer to write?
Oh, the 2.
Yes. Do you see that?
Yeah.
This is our restriction.
Yeah, because the 3 one says that 2 is included, but with the 2 one, 2 is not included.
Yeah,
so
because then this will not be valid. Therefore, you'll go with that. So that is how, and with this, you will get this as minus 1. You get the point.
Right.
So in between interval, as shown here, becomes the domain. And that could be an independent question for you.
Yeah. All right.
Okay.
Tricky, but could be possible.
Yes. Okay, next question. This is similar to just what we did, right? Now you can
so we can skip that. Yeah. Okay. It's a bit of sketching graphs. I feel like this will be in my test, but
let's do it.
Oh, okay.
No problem. Simple. So we'll just sketch the graph of e to the, it is f of x is 2 times e to the power of x minus 1. So let me first sketch the function e to the power of x, right? So e to the power of x
goes through 1.
Of course.
0, 1.
And at 1 it is e, right?
Yeah.
At 1 it is e. So that is how the function is going to be. Now we need to sketch the absolute value of this function. Since it is positive, both are exactly same.
Wait. So do we want to sketch f of x where you have to minus 5? So
Sorry. Oh,
and times 2.
Sorry. Oh, I skipped all that part. E to the power of x. So times 2 and minus 5. So we'll multiply by 2, of course, and then when I do that, this goes to 2, right? And that becomes 2e. So it gets vertically stretched, right? And on this side, it again gets vertically stretched. So all the values will get vertically stretched, and so this is here, right?
Yeah.
Let me
to show a stretch, sir, does it need to be really obvious? Because you can't really show a stretch.
So no, vertically stretched we have shown, right?
Like no, now we have, but in the exam, you know how we don't do the original graph, we just do the finished graph, like of 2e.
Yeah, I'm showing you the steps, which may not be required as you're saying. So what you could do is, let's get back to what you're saying. It makes sense. So on the function, which is e to the power of x, let us write down some values. When x approaches minus infinity, y approaches 0 from the positive side. And when you do on that function, which is minus 5, here, when x approaches minus infinity, y approaches minus 5, correct? And therefore, we'll actually have a horizontal asymptote at minus 5. Is that clear to you?
Yeah.
Now, the second part is that there are key points here, as we just figured out, is then when x is 0, then y value is y, and if x is 1, y value e. So these are good enough for us to figure out. Or you can also include minus 1 and 1 over e. Is it okay?
Oh, okay. Yeah.
Well, so we'll work with these. So when x becomes, the transformation really is, the mapping is kind of like this. xy changes to x value has been unchanged, right? So x value is same. The y value is multiplied by 2 and then take away
-5. Yeah.
and that is what you will do here. So x value will remain same. I'm just doing for these two now. And 1 gets multiplied by 2. So 2 minus 5 is -3. And in this case, 2e minus 3, right? 2e minus 5. So those become the coordinate points of the final graph, correct? And you can find your answer. You can also find the y-intercept of this equation. So that is to say, let's reorganize this. So we'll now work out what is 2e to the power of x minus 5. When is it equal to 0? So that means 2e to the power of x equals to 5. E to the power of x is 5 over 2. And x will take ln on both sides. Do you see that? So x equals to ln 5 over 2. Is it okay?
So I'm getting 0.916.
Yeah, so some positive value. So therefore, we'll actually graph this kind of like this, right? Putting the values which we just calculated. Is that okay? Fair enough?
Oh, yeah. Would it cross at -3 though?
No, we found that y is 0 at ln 5 over 2. Sorry. Let's redo this. 5 over 2 was which point?
On the x-axis where it cuts.
Yeah.
On the y-axis, it cuts at 0 -3, I think.
How much it was? It is positive value, right?
Yeah, 0.916. Yeah. And then you mark that one as -3.
Yeah. And substitute all your points here, right? Just put
Oh,
them.
right, okay.
So we have directly plotted the graph, which you could do. Perfect.
I see. Okay, so that bit's clear. And then
absolute
part
function.
2,
Absolute function. Yeah. Let me just go through it.
just move everything below the x-axis above.
Yeah. So that's simple. So we had our graph, which was, let me now sketch in a different color. Now, absolute function means that we have to reflect this part, right? So basically, that -5 thing comes at +5 on this side. Up to this point, right? This is 0.9, correct?
Yeah.
So that is your horizontal asymptote now. And from here, this point, you have to figure out how much it is. And then, like.
That was -3.
Okay.
Oh, wait. Yeah.
Y equals to 0, whatever you calculate. Put y equals to 0 and get this value.
So yeah, -3.
No, x equals to 0.
So 3.
Yeah. So f of 0 is 2 to the -5. Yeah, -3 we calculate. You're right. So this was 3.
Okay. Yeah.
And this is y equals to 5.
That's 6 marks. So yeah, I think with
lot of it.
asymptotes, you need to be really clear about that.
Yeah, so this is absolute function.
Yeah.
So I hope it is clear now, right? So what is part B?
So deduce the set of values of x for which f of x equals the absolute function of f of x.
So this part is common. Do you see this? So x greater than equal to 0.9, whatever you
6. Yeah.
You can write the exact value also.
Oh, okay. In terms of like e to the power.
Okay. Yeah, 5 over 2 we found, right?
Yeah. And then part C, find the exact solutions of the equation of the absolute function of equals 2.
Yeah. So basically, you have to solve this equation. So at 2 below this 3, right? So we're looking for some point here. Do you see that? So that is what you have to do. So basically,
you take the negative of the absolute.
Yeah. So
piecewise.
Yes. So do piecewise function. So f, that means basically absolute value could be -2 or +2. You get the idea. So solve for -2 equals to 2e to the power of x minus 5. Right?
And then that also equals to
negative of this. Yeah, or you can say this and equals to +2 for 2e to the power of x minus 5. Solve these two equations and get both your answers.
Do you think it's better to do it like that instead of the whole like taking out the negative for the equation.
This
I
is
guess you
better
get the same answer. Yeah, this is better.
because see, we are actually finding this point, right? It is
Right.
same point. For the y value of 2, it is the same point. Do you see the x value same?
Yeah.
You get the idea?
Yeah. So you just need to
Yes.
work out. Yeah. Okay.
So as
That's
you
smart.
understand, so we worked on the same function, the old function which is not absolute value. However, we calculated 2 points and the other one. So one and the second one matches x value. That is the concept.
Yeah. Yeah.
Yes. So basically,
right.
what we are saying is that absolute value of f of x is equal to 2. That basically means we are wanting to, we say minus 2 is equals to 2 and also 2 is equals to 2. Do you see that? And
Yeah.
that is the reason why we equated the same equation on the right hand side with plus and minus 2.
Mm.
And
So
graphically, yeah.
why do they teach us though in school to take out like and do the whole piecewise function? So they'll be like do minus 2 e to the power of x plus 5 equals to 2.
Yeah.
And then
So yes.
because that's kind of tricky.
Yes. What you will do is what schools will do is they will write this as a piecewise function. They write this as minus of 2 e to the power of x. I will write now this as plus 5, means both are negative, right? Where x is less than ln 5 over, what do we get? 5 over 2, right? And it is 2 e to the power of x minus 5 when x is greater than equal to ln 5 over 2. So we'll write this equation. Is that okay?
Yeah.
And once you write this equation, you're going to solve it in 2 parts. One, where x is greater than equal to ln 5 over 2, and the other where x is less than ln 5 over 2. So in this side, you're saying you want to be 2, right? So you say minus 2 e to the power of x plus 5 equals to 2. And here you will say that 2 e to the power of x minus 5 equals to 2, right?
Yeah.
But this is same as, this is actually same as writing 2 e to the power of x minus 5 equals to minus 2. Is there any difference?
Oh, no, not really.
No difference. Do you see that?
Yeah, and it's easier to get my head around your way because you're really understanding the concepts of actually what an absolute function means, because the absolute function of minus 2 equals 2 and the absolute function of 2 equals 2. So you might as well work like that.
Yeah.
All the questions, yeah.
The x value is same. We are reflecting a point which is here on this, right? So the x value is same, whether you calculate for minus 2 or for 2.
Right.
That is the concept of absolute function, right?
Yeah.
So this is a very important thing to understand how my method actually reduces many steps.
Yeah,
and
definitely.
gives you the same thing. Because actually speaking, you're solving this equation only.
That's why I keep thinking, why is there 2 things? Because that you end up getting the same answer, but why am I going the long way, you know?
Yes.
So yeah, okay. So I'll keep that one in mind.
Yeah, sure.
Right. Thank you, sir. That's a really key point. Yeah, I don't know if we have enough time, so because I got the other questions.
Yeah,
So
we'll skip to the next topic. Yes, we'll skip to the next topic. But I think you got good gist of all this. Can you summarize what did you learn in exponential and logarithmic functions questions?
Yes.
How do we solve?
Yeah. So when I was obviously doing it, I found the tricky part for me was we learned all the log rules and the power rule and the multiplication stuff as well. But because I always, even in my book and everything, I've seen it in terms of log. Whenever I see the natural log, I don't know, everything kind of switches off and I'm like, get a bit scared. So it is still the same concept. It's just ln x is still log, but with the base e. So it's not that different from just normal log. And then we sketch the graphs, and again, same principles in terms of transformations. Just because you say e to the power of x doesn't mean you don't. We still do like our x, y, and then do our image point with changing up whatever happens to x and y. So same principles apply, just different like terms and figures you're using. So yeah.
Okay, let's share the next part.
Okay. I think it was this. Yeah, it was. Okay. So I had a couple here.
Okay. You want to do this partial factoring?
Oh no, that's a
Okay.
Actually, I do have a question about that, but we'll go in order.
Mhm.
All right, so 7D. Here, 7D. So yeah, I think we did discuss this last time, but I just
Mhm.
still didn't really understand the concept. I just wanted to get the concept, not just the answer, because
Okay, let's
yeah, I
go
really
through the
wanted to
concept.
understand it.
Can you please read the question? We have this square root function right there. Yes.
Yeah. So g of x equals 3 plus square root x plus 2, where x is greater than or equal to minus 2. So part A, state the range of g. So that was nice and straightforward. I just said g of x is greater than or equal to 3.
So
No,
basically, you find this point. Do you understand?
yeah.
That helps. So this point is at -2 and 3.
Yeah.
Now you
So
can also state the range of 3. So it is greater than or equal to 3. Is it okay?
yeah.
Yes.
And then part B, so this is where you said whenever they say inverse, just immediately write down the domain and range and swap them.
Yeah, yeah.
So
So domain is greater than equal to 3. Is that okay?
yeah.
Because range of G is domain of inverse function.
Mhm.
Right. Next.
And then
Exact
part
value of
C,
x for which this. Okay. So just
yes.
substitute x here. So and solve for it, right? So
Yeah.
that you could do, right?
I did that one. Yeah, that's okay.
Okay, that's okay. Let's
So
clear.
yeah, I got the value of 7 plus root 21 over 2. And
Okay.
then yeah, I had to sub. So actually that's the question I think I remember us doing, where after getting the two values, both the values were positive. So then I had to find the y value to make sure it fit within the range. But then one of those values didn't fit within the range. So it was
Yeah,
only
yeah.
one value. Yeah.
Correct, correct.
Because you know how usually with quadratics you get a negative and then you can easily cancel it out. In this case, it wasn't, so it was quite sneaky. So yeah, I had to do an extra step. And then part D, I just didn't get. So it says so without actually solving that, because it's 1 mark, how do I do it?
Okay. So what is, let me say, what is G inverse of G of x equals to? X, right?
X, yeah.
So G inverse of x is x, right? So that value of x tells you that if I do inverse of this, what do I get both sides? Find the exact value of x for which g of x is x. So x equals to y is basically the line where, can you go back? I'll just sketch there on the graph and show you, right? So let us say we draw a line here which is y equals to x. So y equals to x in this case will be gx is y value is equal to x, correct? So you really found the invariant point where the graph crosses this line. You understand? This is the line
Oh,
y equals to x.
yeah. So you're not going to draw the inverse.
Yeah. So the coordinate of this point is, what was your answer? 7 point, what were you saying?
7 add root 21
So
over 2.
yes. So at that point, both values are same because y and x values 7, whatever you got. Let us say you got AA, right?
Decimal value is 5.79.
Yeah. So Amy, do you understand this concept? When you are asking this question that g of x is x, you're actually finding the invariant point.
All right. So g inverse of g of x equals x is the invariant point.
Yes. So so the point where g of x was x will lie on the line y equals to x, correct? G of x is y value. So it's like AA. You get the point?
I get the invariant point, but on the graph that you've drawn, the you know how the inverse of the graph will be the reflection in the line y equals x.
Yeah.
Is if that cuts the g of x, won't that be the invariant or like a point?
Yeah. I will just draw that graph also. Don't worry. So this is your point, right? So when I make it at 3 3 minus 2 it becomes, correct? So this point gets reflected and comes here.
2 minus 3, yeah.
And so if I draw the inverse of this function, it will actually go through this. Do you see that?
Oh, yeah, yeah.
So this becomes your G inverse X.
So how do we, so to find the point AA, how do we find that?
You just calculated, right? You said G of X is equals to X. What is the value of X you got?
5.79.
5.79. So X value is 5.79 and G of X is the Y value. So Y value is also 5.79. Do you see that?
Oh,
So now if you inverse it, you get the same value because it is the same value.
yeah, because the inverse, like you've drawn, has gone through the point AA. So it
Yeah.
has to be. Oh,
Yeah.
right. So I couldn't picture that at all. I have to see a graph. Oh my God. Okay. So yeah, that makes sense now. So it's all about the way you draw the graph. I was sitting there trying to actually solve it because I found the inverse of the function and the actual.
Yeah.
It's only 1 mark, so I knew there
One
has
mark,
to
yeah.
be
So
an
don't
easier way.
recalculate. Yes. Do not recalculate. Just put the same answer and you may give this reason. So that is good
Oh,
reason, right?
okay, yeah.
Oh.
Yeah. So g of x equals 5.79. And then you said this is the invariant point.
You have to write the exact value, okay?
Okay, yeah. I was just for purposes for you because it's so hard to say 7 plus root 21. Okay, so that was okay.
And you know, this is a hint. They clearly write hence. State the value of A for which G of A is G inverse of A. Is that okay?
Yeah.
So that's what it is.
All right. Okay. But what happened if you get 2 values?
You won't, it's not a function. It is not a function if you get 2 values.
Oh yeah, this is an equation. Okay, yeah. Okay, cool.
So, okay,
it's fine. Maths, it makes sense.
Can you explain me the solution of this question? I think you're still slightly confused about it. Yes.
You think? Okay.
Yeah.
So part A is nice and straightforward because we just substituted the value of the x and we put in the function and we said it's greater than or equal to 3. Then part B, you're trying to find the inverse and state its domain. So it would just be the range of the normal function because the domain and range swap. Part C, find the exact value for x. So I just basically did find, so g of x is given here and just make that equal to x and solve. So I got 2 values and then found the 1 by substituting it back in and seeing if it fit within the range.
Domain.
And then,
yeah.
Oh, in the domain, sorry. And then part D, it's so you've got the normal function and then you've got the inverse and you want to make them equal to each other. So when we sketched it here, you put the line y equals x and then the inverse of that is also going through the point that the line y equals x crosses the g of x. And so because that point is staying the same as the invariant point, and so that's the value that we just calculated. So the point is that the x value will be 5.79 and the y value. So that's why the inverse of g of x is x.
Correct. Absolutely clear, right?
Yeah, it's clear.
Perfect.
Yeah,
good job.
definitely.
So let's move on.
Okay. I think that made sense. It made sense in my head. It's hard to explain though without sketching graphs.
Yeah, I think sketching is important.
Yeah, definitely. Okay. Question 10C I had an issue on.
Okay.
So
let's read the question. Yeah, we'll go from A, right? Yeah, say.
Okay. So part A, we've just got this graph here, and it says the graph consists of 2 line segments that meet at the point Q, which is 6 minus 1, crosses the y-axis at the point 0, 11, point P, and then you sketch on separate graphs. So you got the y equals the absolute function of f of x. So the point Q just kind of flips, and you go 6, 1.
Correct.
Yep. And then part B, it was just 2f of minus x plus 3. So all I did was have the x and the y, and then the image point would be minus x, and then 2y plus 3.
Good job.
So I just took the points like
Make a
you said.
table and do it. Yeah.
Yeah,
And these are the critical points which you are working with, right?
right, P and Q.
That's fine.
Mhm. And then part C. So I might be being really stupid, but I just kind of did not know how to answer it. So on each diagram, show the coordinates of the points corresponding to P and Q. Given that f of x equals a absolute function of x minus b minus 1, where a and b are constants, part C, state the value of a and the value of b. So I got b right as 6. But I didn't know why I just wrote it. So I wanted to understand.
Great. So you want to write the function basically as a x minus b over this, right? So let's write down the function f of x. Let's go back. F of x is equal to, right? F of x is equals to, how do you want to write it? A, let me see the
Sorry, you wanted me to throw, oh yeah.
x minus b minus 1. Okay, it's very clear. Because minus 1, it translated 1 unit down. Perfect. So this is minus 1. And that's why we are getting this minus 1. Graph is vertically stretched and moved right to how many units? 6 units, right? It has used 6 units right, correct? So the value of b is 6. And value of a, how are you going to find? Substitute the given point. Let's go back to your graph. Substitute the given point. Let's go back to your graph. You're given this point. At 0, it is 11, right?
Yeah.
At 0, it is 11. Substitute 0 here and equate it to 11. So we get a times 0 minus 6. 6 is your value, correct? Is equal to minus 1 is equal to 11, correct? So we can now solve for a 6.
Oh, because that's minus 6. Absolute value makes it just 6.
6 equals to 12. Is it okay?
Yeah.
So a equals to 12 over 6, which is 2.
Oh.
Is that clear to you?
Yeah. So it was all about substituting the value of P back in.
Yeah.
All right. Can't you sub in Q?
First value was clear because you moved 6 units right, and therefore B is 6.
Yeah.
You
but how come
one,
you didn't sub in value of Q into the equation? You could have.
No. Q, we have already used the value of Q to find B.
Yeah, I know. Oh, so you can't use it again. Okay.
You get the same thing. You can't use it.
All right. Okay.
So 2 unknowns, 2 points.
Yeah. Okay, so that was clear. And then I had just a couple more. Stupid. Oh, 14b. Oh yeah, 14b. I completely did not know what to do.
Okay, let's read the question.
So given that a and b are positive constants, on separate diagrams, sketch the graph with equation y equals absolute function of 2x minus a, and part 2, y equals absolute function of 2x minus a plus b. So they were fairly straightforward.
So here, when you write this, you have to write this as 2 common factor, x minus a by 2. You see that?
Mm-hmm.
You have to, so that you are clear that it is horizontally compressed by a factor of half, and it is moving a by 2 to the right, and this one is moving plus b up, right?
Mm-hmm. Yeah, so then parts B was given that the equation absolute function of 2x minus a plus b is equal to 3 over 2x plus 8. It has a solution at x equals 0 and a solution at x equals c. Find c in terms of a.
In terms of a. So it has a solution at x equals to 0, means both sides are same, correct? Both sides are same. So that is what it means. And a solution at x equals to c. So for both, it is same. So we can substitute x equals to c and x equals to 0 to find what right hand side is. So
what do you mean by both are same if you sub in x equals 0?
Okay. given this equation has a solution at x equals to 0. One solution is x equals to 0. Let's find the solution. So what I will do here is that you can divide your domain into two portions. One when x is greater than equal to a by 2, and the other when x is less than a by 2. Is it okay?
Okay.
So if it is less than a by 2, we'll use a negative value here. So it is minus 2x plus a plus b equals to 3 over 2x plus 8. And on this side, we'll use the value as such, which is 2x minus a plus b equals to 3 over 2x plus 8. Now it says that the solution is x equals to 0, which is definitely less than a by 2. So x equals to 0 is on this side. Substitute 0 here for x. So when you substitute 0 here, you get a plus b equals to, that is 0, we get 8. Is that okay? So b is equals to 8 minus a. So the value of b is 8 minus a. Is that okay?
Yeah.
So now, other solution is c, means on this side, the solution is c. Substitute b as 8 minus a here. So we have 2x minus a, and instead of b, I am writing plus 8 minus a. Is that okay? Equals
Instead of, yeah, 8.
right. Now, solution is x equals to c. So I'm going to replace x with c now and simplify this equation. So now I'm writing this as 2c, and I'll take other things on the right hand side. Is that okay? And bring, so minus 3 over 2c I'm bringing on this side equals to 8 and 8 cancel, right? And we take minus a is 2a. Is that clear to you?
Yeah.
So basically, this is c, right? This is c. So let's take c common. So there's less space here, so I'm doing here. So let's take c common. So we get 2 minus 3 over 2 equals to 2a. So which is c common, 4 minus 3 over 2 equals to 2a. So c is basically 2a times 2 over 1, right? Times 2.
Yeah.
4 minus 3 is 1. So c equals to 4a.
4a.
Do you get the solution?
Oh, I see. So it's like a piecewise thing again.
Yes, yes.
Oh, right.
Yeah. So here we had to split because, it is not a direct equation. We got this plus b.
Right. Yeah, the plus b.
I could have taken that and done it the other way, but this is simpler to understand. Since we're saying one solution is on the left side and the other is on the other arm, correct?
Oh, see, I didn't understand what they meant by that.
Yeah, basically, So basically, that was the problem. So we have this equation. We know the graph is somewhere like this, correct? And some solution of this equation, which is 3 by 2x. So our line went something like this, and we are looking for these points.
Oh,
right?
yeah.
Get the idea.
But one of them had to be at x equals 0.
So one of them is on the left side of the arm, right? Which is a by 2, and the other one is on the right side. You get the idea?
Yeah. And so, yeah, we were calculating.
So we have to put two different sides and then figure it out.
I see. Okay. See, I think when I get stuck, I just need to like draw something, because that makes so much sense now. Like I could have done it if I looked at it, because that's a normal like piecewise function kind of thing.
Okay. And
all right.
This slope, this gradient is 2. So that means this is very steep. Absolute function is very steep, and the line is 1.5. So line is definitely cut at 2 points. Is that clear?
Yeah. And if it was the same gradient, it would still cut 2 places.
No. If it was same gradient, let us say same gradient, if you draw, it will cut at 1, same or less. So if it was same, let's say this line is same, right? So it will be parallel to this. Is that okay? So it will only cut on one side.
No, I mean, what happened if the gradient was 2?
Oh, line gradient was 2, then it was parallel, right? So it will be parallel. So it will cut only on one side. If I change this line to 2 or more,
Mm-hmm.
2 or more, then it is only 1 point. Because if the line is like this, I mean, it will never cut on that side. Do you see that?
Right. Yeah, so only on that one. Okay. Makes sense.
Yeah.
So only if it's 2 or less, you'll cut 2 points.
Yes. You have to, when you graph it, you can visualize it, right?
Right, right.
And one thing very important we have already assumed here is because they gave you a solution, that this point is above 8, right? Because
Yeah.
they said one of the solution is this, correct?
Yeah,
That is why.
I see. Okay. That's clear. Okay, and this is kind of a general question now. So, with partial factoring, so like let's say question 15, when I did it, it's fairly straightforward. You can either do it by equating coefficients or like multiplying them out, and that makes sense. But then for question 16, when I did the similar approach, so let's say I make that equation equal to a over x plus 2 plus b over 3x minus 1. I solved it and I lost a solution. I lost a value, a constant. So what I had to do was then I had to do long division and then get an answer and then partial factorize. So how do I know when to do long division and get a constant and then when not to do?
You have to check the degree.
Oh, so if I expand that out, I'm going to get an x squared.
Yes, because it is not in the simplest form as such. So if you have a fraction, let's say 4 over 3, then it's better to write this as 1 over 3. You see that?
Yeah.
So here you have to first divide and get what is the whole number. That is the constant you're talking about.
Yeah. So that's where I lost out. Okay.
And then
so
for the rest, remainder you put it in fraction.
Right, because for this question here, let's see, you got x squared and then you times x again, you get x cubed. So you know that you don't need to find a constant.
No, you don't need to find a constant. So
Okay.
it is a constant k plus this. You're right.
I see. So yeah, that was just a general question.
Very
and then
good.
Okay, cool. So that's a key point there. And then final arithmetic one, just 2 questions.
Sure.
Okay. I think it's that. Okay, so
yes.
So 2C.
Okay.
That part there. So a boy saves some.
Tell me first, what was the solution of A? Read the question, please.
Yeah. Let's do that. A boy saves some money over a period of 60 weeks. He saves 10p in week 1, 15p in week 2, 20p in week 3, and so on until week 60. His weekly savings form an arithmetic sequence. So part A, find out how much he saves in week 15. So I did that by using the formula. So U15 equals 10 plus 15 minus 1 times 5. And I got ATP.
So find how much he saves in week 15, right? So starting with the value of 10, common difference being 5, right?
Yeah.
And week 15 means 15 minus 1. You got your value. How much was it?
ATP.
Okay. Right. And then calculate the total amount he saves in 60 weeks. So you can use the sum formula, right? And then find this figure.
Yeah. So I got 9450.
Okay. Now what is the next question?
So yeah.
No problem. So Amy, can you, so what is the problem you're facing with question number 2?
So 2C, I just don't get it. So yeah, the boy's sister also saves some money each week over a period of M weeks. She saves 10p in week 1, 20p in week 2, 30p in week 3, and so on, that her weekly savings form an arithmetic sequence. She saves a total of £63 in the M weeks.
Okay, so all these monies which are given to you are in pennies, right? And all of a sudden we have 63 pounds, right? 63 pounds. That means it is 6,300 pennies, right? So now use the sum formula, which is Tn equals to n over 2 times 2a plus n minus 1 times d, correct? So we
Yep.
know that this is 6,300 equals to m over 2 times 2a, 2 times 10, plus m minus 1 times d, which is 10.
Yeah.
So we get 6,300 equals to, let's open the bracket, right? So multiply 20 by m by 2. What do you get? Let's open the bracket. So you get 2 and 2 cancel, so you get 10m. And when you do with this, we get plus m, and 2 cancel with this 5, right? So you get
5m minus 1.
5m times m minus 1. Is that clear to you?
Yeah.
And now we can bring the terms together, open the bracket. So we have 0, I'll keep 6,300 here itself, equals to 5m
5m
squared
squared
minus 5m plus 10.
plus 10m.
6,300 equals to 5m squared minus, and that becomes plus 5m. Right? So we get the left hand side, which is we have 5m common, and we have m plus 1, and we have 6,300 here. Now we divide by 5, so we get 6,300 divided by 5 equals to m times m plus 1. Is that clear to you?
Yeah.
So when you divide, what do you get?
1260.
1260. So 126. Well, when you divide this, 5 times 1, 1260 equals to m times m plus 1, right? Check this out. Is it same?
Yeah.
So you can write this
So
as
the last step. Do you just say 1260 is 35 times 36?
or you can write this as 1260, right?
Okay.
One and the same thing. Yeah, and either way you could say, right? This is what
Got
you.
it. So yeah, clear. So it's just the units were important.
Yeah, units are important. So we had the value in pounds. We have to convert that in pennies, and then use this particular equation. Perfect. So that was it.
Yeah.
Okay. So with this, we end this particular solution. I hope that helps.
That was super helpful, sir. Thank you so much.
Great.
Yeah, so it was kind of a bit of variety with the logs and like arithmetic sequences and also the graphs questions. So yeah, now I can see where my issues lie and I can work on that. So yeah, thank you, sir.
Thank you.
I hope you learned from this particular video. Feel free to write your comments, share your views, and share questions if you have. You can also join us sometimes on our Zoom calls. You can send a request to me on the email address given here. Thanks a lot for your time and all the best.